What if the universe wasn't silent? What if, instead of staring at frozen stars, we could catch the cosmos in motion, watching it flare, flicker, and evolve in real time? For most of human history, astronomy has been a still photograph. We pointed telescopes at the sky and captured moments, snapshots frozen in time. But the universe doesn't sit still. Stars explode, black holes flare, entire galaxies collide. And now, for the first time, we have a telescope built not just to see the universe, but to watch it unfold. High in the mountains of Chile, the Vera Rubin Observatory has opened its eye to the sky, with the largest digital camera ever built for space science, a staggering 3.2 billion pixels. It's not just taking pictures, it's capturing the story of a living cosmos. Every few nights, it scans the entire southern sky, hunting for change. It can spot a supernova just hours after it erupts. It can alert us to asteroids heading our way. It might even help us find the long-theorized Planet 9. But why does this matter? What's so revolutionary about watching the sky instead of freezing it? In this episode from Scientific Facts, we'll explore how the Vera Rubin Observatory is revolutionizing astronomy, what it sees, how it works, and why its discoveries may change everything we know about the universe. For centuries, astronomy has been like a photo album, a collection of still frames. We've mapped stars, galaxies, and nebulae as if the cosmos were a static masterpiece. Beautiful, yes, but motionless. Yet space is anything but quiet. Out there, stars collapse in seconds. Black holes devour gas clouds in a blaze of radiation. Entire galaxies twist and distort each other in slow-motion collisions. And sometimes, the light from these cataclysms reaches Earth for just a fleeting moment, a moment we've often missed. That's where time-domain astronomy comes in. Rather than capturing space as it was, time-domain astronomy captures space as it changes, night after night, year after year. It's the study of cosmic motion, variability, and surprise, and it's revealing an entirely different side of the universe. Sudden flashes called transients, like supernovae, gamma-ray bursts, and tidal disruption events, happen fast and fade even faster. Blink, and they're gone. And for decades, many of these events went unnoticed because we weren't watching the sky often enough. The Vera Rubin Observatory changes that. It turns astronomy into something more like a live broadcast. Every 30 seconds, it takes a new exposure. Every few nights, it scans the whole visible sky again, comparing frames, tracking differences, catching the cosmos in the act. This is what makes Rubin revolutionary. It's not just taking images, it's watching a story unfold. And that story is just beginning. To build a telescope capable of watching the entire universe change, scientists had to find the perfect place and create something the world had never seen before. They chose Cerro Pachon, a 2,700-meter peak in northern Chile's Atacama Desert. Remote, dry, clear skies for more than 300 nights a year. It's one of the best spots on Earth to observe the stars. But the location was just the beginning. What followed was one of the most ambitious telescope builds in history. At the heart of the Vera Rubin Observatory is an 8.4-meter primary mirror, huge by any standard, but also uniquely designed. It combines a primary and tertiary mirror into a single monolithic piece of glass, reducing size and increasing efficiency. Above it sits the crown jewel, the LSST camera. At 3.2 billion pixels, it's the largest digital camera ever built for astronomy. It's the size of a small car, weighing over 3 tons and powerful enough to detect a golf ball from 25 kilometers away. But it's not just about size. It's about speed, precision, and vision. The Rubin Observatory's camera captures a 9.6 square degree field of view with each image, about 40 times the size of the full moon. That means it can image huge chunks of the sky in a single shot, making rapid scanning possible. And to handle all that data, a state-of-the-art processing system built to manage 15 terabytes every night issuing alerts to the scientific community in under 60 seconds. The entire project took over a decade to plan and construct, with a final price tag of more than 700 million, backed by global institutions committed to unveiling the dynamic universe. This isn't just a telescope, it's a machine built to keep up with a living cosmos. And what it's about to witness is going to change everything. At the heart of the Vera Rubin Observatory is a bold mission called the Legacy Survey of Space and Time, or LSST, and its name says it all. It's a 10-year cosmic census, a plan to capture the entire southern sky, again and again, every few nights, for a decade, not just as a still map, but as a series of changes, a living, breathing time-lapse of the universe. Here's how it works. Every night, the observatory takes thousands of wide-field exposures, each covering a vast swath of the sky. These images are compared to previous scans, looking for differences. New dots of light, sudden flares, fast-moving objects, anything that wasn't there before. If something has changed, say a star brightens unexpectedly, or an asteroid darts across the frame, the system flags it. Within 60 seconds, that alert is sent out across the globe, allowing scientists to react, follow up, and study the event in real time. The LSST is expected to produce over 60 petabytes of data. That's 60 million gigabytes. Too much for any single team to handle. So Rubin's entire database will be public, inviting researchers, citizen scientists, and AI systems to dig through this cosmic archive. But the real magic lies in what these changes reveal. Each flicker might be a newborn supernova. Each streak might be a near-Earth asteroid. Each subtle curve in the background light might hint at invisible dark matter. Rubin doesn't just record what's visible. It catches what's vanishing, emerging, and evolving. This isn't just observation, it's anticipation. And what the Vera Rubin Observatory is poised to discover could rewrite our understanding of the universe. So what exactly will the Vera Rubin Observatory discover? In short, everything that moves, flares, fades, or flies. First, there are supernovae, the dramatic deaths of massive stars. Rubin will catch thousands of them, often within hours of their eruption. That timing is crucial. Early observations help astronomers decode what triggers these cosmic blasts and how they seed the universe with heavy elements like gold and iron. Then there are asteroids. Rubin is expected to discover millions, including many that orbit dangerously close to Earth. It could become our most powerful early warning system for planetary defense, catching small, fast-moving objects before they're ever visible to ground-based observers. In fact, in mid-2025, Rubin's pre-science tests already detected its first asteroid, proof the system is working even before full operations. But Rubin isn't limited to what's nearby. It will also help uncover the secrets of dark matter and dark energy, two invisible forces that shape the universe but remain almost completely unknown. By observing how galaxies cluster, how light from distant objects bends as it travels through space, and how the universe expands over time, Rubin will generate some of the most detailed cosmological maps ever created. And then there's the hunt for the mysterious Planet 9, a theoretical giant world lurking far beyond Neptune. Astronomers suspect it's tugging at the orbits of icy objects in the outer solar system. Rubin's repeated, wide-angle scans may finally spot it, if it's out there. Even more intriguing? Rubin may detect events we haven't even imagined. New classes of transients, optical counterparts to gravitational wave detections, exotic phenomena that only appear once and vanish forever. And some of those discoveries may even affect us directly, like the early detection of hazardous asteroids or fresh insights into the very fabric of space and time. Because Rubin's true gift isn't just seeing, it's catching the universe in the act. And in doing so, It may illuminate the darkest corners of the cosmos. The observatory's name isn't just symbolic. It's a tribute to a woman who helped change our understanding of the universe. Vera Rubin was an astronomer who looked where others hadn't and saw what others missed. In the 1970s, while studying the rotation speeds of galaxies, Rubin noticed something strange. The stars on the outskirts of spiral galaxies were moving far too fast. According to Newtonian physics, they should have been flung into deep space, but they weren't. Something invisible was holding them in place. That something became one of the biggest scientific mysteries of our time: dark matter. Rubin's observations offered the first clear, persuasive evidence that the universe is filled with unseen mass, outweighing the visible stars and gas by a factor of 5. Yet for decades, her groundbreaking work was dismissed or ignored by much of the scientific establishment. Now, decades later, her name crowns one of the most ambitious telescopes ever built. It's a fitting honor, because the Vera Rubin Observatory isn't just searching for answers. It's following in her footsteps, looking into the shadows of the universe to find what others might overlook. It's watching the sky change, just like she did. The Vera Rubin Observatory is just beginning its mission. Following its early test images in 2025, Rubin is now preparing for full science operations, expected to run for an entire decade. During that time, it will capture over 500 petabytes of raw data, map 20 billion galaxies, and track the movements of more objects in the sky than ever before. But Rubin isn't working alone. It will operate in tandem with other next-generation observatories, like the James Webb Space Telescope, which sees the ancient universe in infrared, and ESA's Euclid, which is already mapping dark matter using gravitational lensing. Then there's SphereX, NASA's new infrared spectrograph, scanning the sky for signs of cosmic inflation and galactic ice, and ground-based gravitational wave detectors, which alert astronomers when two black holes or neutron stars collide. Rubin is the missing link, a dynamic surveyor of the visible sky, catching the optical counterparts to these deep space events. When something strange happens, when light flares, disappears, or moves unexpectedly, Rubin will be the first to know. Its real-time alerts will turn the global astronomy community into a rapid response team, able to point other telescopes at new discoveries in minutes, not days. And in that coordinated effort, we may uncover entirely new types of objects, new physics, new rules. This is what comes next. Not just a clearer picture of the universe, but a universe that reveals itself in motion. For centuries, we studied the stars as if they were fixed, unmoving points in a silent sky. But the Vera Rubin Observatory is about to change that. With every sweep of its massive eye, it will capture a universe in motion, supernovae, shifting galaxies, dark matter trails, and the fleeting phenomena no one has seen before. It's not just a telescope. It's a time machine, a warning system, and a cosmic storyteller. And it's only just getting started. If you want to follow what it finds, if you're curious about the hidden, the unexpected, and the constantly evolving universe, you're in the right place. Here on Scientific Facts, we break down the science behind the discoveries and dive deep into the mysteries that keep unfolding. Thanks for watching. If you want to see where the universe takes us next, subscribe to Scientific Facts. We're just getting started.